I'm Emily, and today I'm going to talk to you about the most recent annual update for this software ecosystem. The development teams at GOM and Zeiss are constantly working to address changing customer needs as their processes and capabilities evolve. So the Capture 3D engineering team has hit the books and is standing by in our offices across the country to bring you our Cliff Notes for the 2022 version of Zeiss Quality Suite. Joining me today is our application engineer, Kyle.
Thanks, Emily. So we have a lot of good features to talk about. We've received really good support from our customers, and I'm excited to share what our top 10 features are in this year's software.
Let's start by talking about the Zeiss Quality Suite ecosystem. What can you tell us about that?
So the Zeiss Quality Suite is exactly like you said, it's an ecosystem. So really it's our one-stop shop for all of your industrial quality needs. And in this Zeiss Quality Suite, we have access to our GOM software that we've grown to know and love, like GOM Inspect. But also in there, we have access to a forum. We can see trainings and get e-learnings from there, access sample data. The Zeiss reverse engineering software is now also part of this suite. And there's also some added functionality for communication between the GOM software, PyWeb, and Calypso. So lots of fun stuff.
Yeah, I would say so. Some very important changes. I heard about this new feature on our list called a hyperscale recalibration.
Yes.
What is it and why is it important?
So this one's really good, one I'm personally pretty excited about. So with hyperscale recalibration, we're able to recalibrate our sensor with one single measurement position of a calibration artifact. We can either use a bar or the current panels that you've probably seen. This is really nice because we're able to compensate for temperature changes before each measurement. So with just one shot, we're recalibrated.
Can current customers use this with their existing sensors?
Yeah, so any of our current sensor models that we offer are compatible with hyperscale recalibration.
Can this feature even be used with our automated solutions?
I'm glad you asked that because yes, absolutely, we can use them in our scan boxes, and we can even automate the measurement series so that it takes this recalibration shot before each measurement.
If that's just the first feature we're talking about, I can't wait to hear about the rest. I want to go ahead and turn it over to our Washington office where we're going to have Tyler talk to us about DWARP, and then Rob is going to talk to us about the inspection details tab. Kyle, what do you already know about DWARP?
DWARP is another really good feature. It allows us to simulate the measurement of a plastic part in a virtually clamped state. So we can measure it in free state and look at what that part would look like if it were clamped. And we're doing that all virtually, which allows us to save time and money. We don't have to design or build any fixtures for our parts.
And what about the inspection details tab? What's that all about?
Again, another one personally I'm excited about. So we've added some really good visualizations, especially for GD&T checks. Previously, through scripting, playing around with some visualization, creating these crazy report pages, I could get some pretty good results. But now that's all available at the click of a button, and there's some really new and exciting visualizations that Rob's going to show us.
That sounds like it's going to be really exciting. Let's go ahead and get to it. Sending it over to you in Washington.
Thanks, Emily and Kyle. What I have here is a thin plastic part that has warped during the cooling process after it had been molded. These three LED indicator cutouts are not in the correct location, as you can see. However, once this part is assembled to its metal base plate through holes here, here, and here, it's very likely that these LED indicator cutouts will be in the correct location. Historically, the only way to make sure this was the case was to bust out your cheese plate and rig up some sort of clamping fixture and measure your part again. However, with the DWARP package available for free with GOM Inspect Pro 2022, it's possible to simulate this clamping in software. To do this, we first need to determine where we're going to hold our part. I'm going to hold our part here in these 4 cylinders and with a plane on the bottom. These 4 cylinders and that plane make up the datum features of our part and constrain all 6 degrees of freedom, meaning they're a good choice to use as holding locations for our part. Next, I need to determine where I'm going to clamp the part, and I'm going to clamp it at these 3 locations here. One on either side of the part where we have obvious low spots, and another here where we have a very significant high spot. Once we figured out where we're going to hold the part and clamp the part, we can create a deformation model. The deformation model contains all of the information on the material properties and shape of the part to allow the software to calculate how clamping our mesh will change its shape. Once we have all of these pieces, we can dewarp our mesh. And I've taken the liberty of calculating our dewarp mesh ahead of time for us, and we can take a look at those inspections again. You can see now with our dewarped mesh, the LED indicator cutouts are all in the correct location. What this means is that we can be reasonably confident that when this part is assembled, these features will work for production purposes. What's really cool about the dewarp package, besides the fact that it's free, is that it is totally parametric. Any mesh you add to this project template will have the exact same calculations performed, meaning that you can have all the benefits of a custom-made clamping fixture with none of the cost. I'm really glad I got to show you guys this cool feature of our software, and now I'm going to pass things off to Rob, who's going to show you all of the really useful visualization options added with the Inspection Details tab.
Thanks, Tyler, for that excellent explanation on the new dewarp function. My name is Robert, and today I'll be talking to you today about the Inspection Details tab. The Inspection Details tab can be found at any of the docking stations around the 3D view. If you don't have it immediately in front of you, you can add it using the plus button found on those docking stations. And so the Inspection Details tab is a new way to visualize a lot of the data and graphs that we have seen before. And so in this diagram for roundness, we now have a cross-section visual for our roundness check. And so what we can see is what's happening exactly at this height of the cylinder. Now, it automatically highlights the section with the maximum or minimum deviation with these two indicating dots. And if we highlight a individual section on the right side of the cylinder, we can see what min and maximum points are at that height. Now for flatness, we have a new isometric view, which I kind of like to think of as a topographic map where we can visualize the peaks and valleys of the area that we are inspecting. You don't have to visualize it like this. We can change this in the settings as a top-down view. And this is a more classical approach and easier to visualize some simpler geometries. Now, this isn't just for diagrams. We are also able to show tables. And so if I show all my inspection values, we can see a simple table that pops up with the name of the inspection element, its tolerance, and its deviation. This is a fairly simple table, and we can also edit that in our settings. And we can change this to a first article inspection table, which contains a lot more information about what's going on with our part. Again, so we scroll down here and we're showing all our visual options. And so in this section, we can now see a diagram of our inspection section, and it kind of unfolds that inspection section and shows us what's happening across that piece. Now, clicking one last button up here, we have tolerance status of visible elements, and we can see what is within tolerance, out of tolerance on a global scale, and get a good overall picture of how our part was made. These aren't restricted to just the tab. We can place any of this information into a report page. And so here I have a cross-section of our roundness check at the point of maximum deviation inside a report page to better display that to my stakeholders. This isn't only restricted to single parts. We can see what happens in trend projects as well. And so we can now see the deviations of a minimum and maximum point across the position of this plane. We can see what's happening across many stages in our part up in the Inspection Details tab. Thank you all for this quick preview on Inspection Details. If you want to find more information or review the contents you've seen here, you can go to the Zeiss Tech Guide. And thank you very much. Back to you, Kyle and Emily.
Thanks so much, Washington team. That was great. Next, we're going to head over to North Carolina, where Dane is going to talk to us about surface defect comparison on actual stage.
Surface defect comparison on actual stage. I know that sounds like a mouthful, but really this just allows us to compare color maps to a reference part in a stage project. So if we want to look at defects across multiple parts, we can actually reference a part with maybe some known acceptable defects.
That's going to be incredibly useful for our customers out there who spend a lot of time looking at defects. All right, let's go ahead and have them take it away in North Carolina.
Thank you, Emily and Kyle, for that introduction. we're going to take a closer look at an update to surface defect comparison on actual stage, which is relevant for stage projects. Surface defect mapping is a computational stoning method for detecting surface defects on an otherwise smooth surface. The new option called Only Display Deviations Larger Than in Definition stage allows us to find important defects while ignoring others. We do this by referencing a particular mesh stage that represents an acceptable surface. This essentially allows us to filter out defects that we know are allowable based on a good known master part. The new update requires you to have a stage project with nominal and actual surfaces. We create the nominal surface, the surface defect comparison on actual, then the surface defect comparison on actual stage, and we choose our new option. Here we are filtering defects that are allowable referencing a certain stage. When we choose our new option, we are completely ignoring any deviations that fall under that of those of the reference stage. This option now lets us filter out any color plot visuals that are non-essential for the inspection process. As I scroll through the deviations on actual versus actual stages, you can see how the new feature really hones in on just the deviations that are relevant for inspection. That's it for me today. I hope you guys enjoyed watching me dive into this new feature a bit and see maybe how it can help improve some of your inspection processes. Back to you guys.
Thanks, North Carolina. That was very helpful. So next we're going to head over to Michigan. But first, I want to stop for a second and talk with Kyle about photorealistic rendering. Well, you know what they say, picture's worth 1,000 words, and I see you have your laptop there.
I do.
You want to go ahead and show us?
Yeah, let's do it. Let's jump in. So photorealistic rendering, this is a really unique feature. But what we can do is you can take and virtually assemble your part in GOM Inspect Pro, and then we can inspect them in a realistic environment of our choosing using a 360 photo. We can even customize the environment, customize the lighting, and create visual inspections in that lighting environment of our choice.
Thanks so much for that great example, Kyle. Now we're going to go ahead and head over to our Michigan office where we're going to have Leah and John show us some more new features.
I'm excited for this one, being a former Michigander myself, to see what them out in Michigan are working on for us. And then we're going to head over to Leah, who's going to talk about some new element constructions. And John's going to dive into how we can export from our software directly into PyWeb for further analysis.
Sounds great. Let's get started.
Today, I'm going to show you some of the new construction features that are available in GOM Inspect 2022 on this gearbox housing. I'm going to begin by showing a new menu option available in our Fitting Plane dialog box. It will begin by selecting Construct, Plane, Fitting Plane. I will then zoom in and control-click on the desired plane that I would like to construct. You'll notice that the software defaults to Gaussian Best Fit. You can pull that option down to select Gaussian Best Fit Outer. When using this option, the software computes all possible planes so that all of the selected points fall below that plane. The normal, or orientation of that plane is calculated by the average normal of all of the selected points that you can see here in red. Another new feature in GOM-INSPEC 2022 is the ability to construct a distance between two lines. You can also use this function to construct a distance between two cylinders. So I'm going to make these two cylinders here visible. You'll notice we have cylinder 1 right here and cylinder 2 over here. I'm going to go to Construct, Distance, Two-line distance. I'm just going to Control-click the tag of cylinder 1. You'll notice it populates in the dialog box. Control-click cylinder 2. Create and close. I can then apply my measuring principle and output the distance. With GOM-INSPEC 2022, we are now able to construct a division point or a midpoint along a line. To do that, I'm going to use the center line of cylinder 1. I'm going to construct point, point from line. Under line, I'm going to Control-click on the tag of cylinder 1, which will select the center line of that cylinder. GOM-INSPEC already had the ability to construct a first point, which you can see has populated here on the top of this line. The second point, which shows up on the bottom of the line. If you select division point, that will create your point in the middle of that constructed line. That is it for me for some of the new construction methods. I will now pass it over to John so he can discuss PyWeb exports.
Thanks. I'm excited to show you how quick and easy it is to export a PyWeb results file from our new software. This file can then be directly imported into the PyWeb via the PyWeb Auto Importer. Let's get started with the demonstration. For our PyWeb export demonstration, I've opened up the Zeiss Quality Suite 2022. I am inside the inspection software. You can see we've got a sheet metal part here that we've already got all the inspection done. What I want to do is pull up all my inspection elements here, and then I want to highlight all of those labels. So I've got them highlighted. I then want to go up to File, come down to Export, go over to Inspection, down toward the bottom is PyWeb. So I'm going to choose my folder destination I want to save the file to. I also need to choose a name. So let's just do sheet metal inspection. My format. So you've got two different options in here. You've got PyWeb version 1.0, PyWeb version 1.1. So they're very similar. PyWeb version 1.0, you can export the XYZ deviations, normal deviations, deviation for diameter, whole length, whole width, and angle. With the version 1.1, you can also, instead of just doing your normal direction, you can also do trimming. So let's just go ahead and do version 1.1. We do need to make sure that this box is selected to use the PyWeb Auto Importer. So go ahead and just, if this is unselected, make sure you have that selected. Down here at the bottom left, we do need to edit our keywords. So in here, you can fill out all of this information. Again, just basic information here, job number, date, time. We're going to go ahead and say OK. And you can see where it says at the bottom here, we've got 19 elements that will be exported, 19 geometries, 87 tolerances. Let's go ahead and say OK. I'm going to go ahead and overwrite one. And to take a look at that file that we just exported, this is what the file will look like. So you can see you've got all the information you filled out up here at top. All your elements, your deviation, XYZs, normals, diameter, length, widths, angles if you had any. We didn't have any in there. And that's your file that you can then use to auto import into the Zeiss PyWeb software. So in conclusion, this is just one more great export option for our customers to use in the Zeiss Quality Suite 2022. With just a few clicks and a quick dialog box to fill in, you can export all your results to a file that can be read into PyWeb software automatically. This is a great optional export tool to help our customers store, analyze, and report the production and prototype inspection data from 3D scanners, CMMs, CTs, etc. in one place. I hope you enjoyed this quick demonstration, and thank you for your time.
Thanks to everyone in Michigan. That was some great information. Next, I'm going to go ahead and send it over to Connecticut, where Greg is going to talk with us about some updates to GOHM Blade Inspect. What can you tell us about GOHM Blade Inspect already, Kyle?
So GOHM Blade Inspect, while it's great and has been great, there's some even better enhancements that have been done this year. Oh. And Greg's going to show us what that looks like. But I think it's some features that our customers are going to be excited about, especially the ones in aerospace power generation that are doing this type of blade analysis.
All right, you hear it. Those in aerospace and power generation, listen up. Over to you, Greg.
Thanks, Kyle and Emily. As you mentioned, GOHM Blade Inspect Pro has some very powerful tools with some great new features for 2022. Some key new tools include virtual balancing of bladed assemblies like IBRs and BLISKs, autopilot to integrate tactile data from Calypso into our blade inspection tools, and 3D throat area inspection. Today I'll specifically be covering the new 3D throat area inspection. And throat area as a whole is a measurement of the minimum surface area between some surfaces, in this case, a passageway between our veins. So to get into the software side of things, the measurement is easier and faster to create than ever before, with just a few simple steps to follow. So we go right up to our quick access toolbar, go into 3D throat area. We have to select the surrounding surface that the area will be between. Our initial boundary curve, which the boundary curve is where we expect that minimum zone to be nearby. And there's some parameters to dial in depending on the size and geometry of our part. From there, we can hit create and close. And in a few seconds, our throat area is created. The last step is to check with our iInspect wheel for area. And within a few simple clicks, we have our nominal, our actual throat area, and the deviation between the two. We can also use this tool to not only check for size and area of that minimum zone, but also the position of that minimum zone and view it as a pass-fail. So to wrap up, this new form of 3D throat area inspection has a lot of benefits, such as being easier and faster to create. It inspects much more of our part as a whole, and it provides much closer correlation to fluid simulation results than previous approaches. Thanks for tuning into my side of things, and back to Kyle and Emily.
Thanks so much, Greg. So those are the top features and updates. If you are new to GOHM Inspect and the Zeiss Quality Suite, now would be a good time for you to experience this software for yourself. Visit Capture3D's website and sign up for your 14-day trial. It's really easy to get started and there's no obligation. So Kyle, where should people go if they want to learn more about the latest Zeiss Quality Suite features?
So the best place to start would be the Zeiss Quality Training Center. It's free to register. And we have webinars, deep dives, e-learnings, going through some of the features that we've even talked about today. And also, I just want to tell people to always feel free to visit our site at capture3d.com, where we have a live chat that's available if they have any questions.
That sounds great. Thanks so much. And that wraps up our top 10 features of the Zeiss Quality Suite for this year. And we're super excited to have brought you these new updates today. Thank you so much for joining us, Kyle.
Thank you.
Thanks to our team of application engineers across the country. And thanks to you for joining us today. We have lots of events all the time, so make sure to subscribe if you haven't, and have a great day.